Good morning, everyone. My name is Vivek. I work on LB solution for eBay and PayPal, and my colleague who worked with me, VJB, he's a lead developer in my team. So today I'm gonna be talking about load balancer as a service at eBay and what we did at eBay to take it to next level to meet our requirements. So a little bit about eBay. eBay and PayPal together has like 3 million customers. They drive a lot of traffic to eBay, and most of the traffic is powered by eBay Cloud. Part of eBay Cloud is running on OpenStack, and that's where we come into picture. So agenda for today's presentation is I will discuss how we deployed our multi-region, multi-VPC architecture of cloud and LBaaS, and then how we added value by adding global load balancing between regions to address DR capabilities. And then I will be discussing how we made LBaaS agents highly available and automated them. And in the end, I will wrap up with discussing advanced load balancer scheduler to do a selection of what vendor and LB to use. Okay, skip that slide. So I'll be discussing how eBay Cloud, very briefly, how eBay Cloud is designed. So we have one global orchestration across all the regions. Then we have multiple regions in eBay at different zones to address DR issues. Each region has availability zones, and availability zones are where all the controllers, storage, compute network sits. And then each availability zone has multiple Nova cells where hypervisor goes in. So LBaaS deployment architecture. So if we just focus on one availability zone, this is how it looks like. So I will just talk about how LBaaS is deployed in one availability zone. So we have Neutron controller running active-active in one AZ. Each Neutron controller has an LBaaS driver, sorry. And LBaaS driver are registered, LBaaS agent register themselves with LBaaS driver. Each LBaaS agent is an entity which manages one cluster of LB pair. So in this example, in this slide, we have two LBaaS agents. They are managing two different LB clusters. Now, everything is running in active-active mode in Neutron, LBaaS driver, LBaaS agents, and LB. LB are like hardware LB devices or virtual appliances. The LBaaS agent itself, only LBaaS agents are running in active standby. So to achieve high availability on LBaaS agent, we have made them configurable as with pacemaker. So we have pacemaker component installed. Pacemaker, what it does is it detects on what agent is currently active and managing LB pair. And if LB pair is, if LBaaS agent somehow goes offline, the other LBaaS agent will take over and start managing their LB. So this is how our LBaaS deployment architecture looks like. Okay, next is global load balancing. So we discussed about regions, right? Each cloud, the scope of cloud is limited to a region. Now, if that region goes down, we don't want our customers to lose their services or applications. To address those issues, we introduced global load balancing in cloud. For this, we had to go outside the cloud to achieve this. As you can see, cloud is limited to each region, and then we used F5's GTM load balancing to configure it with. So GTM load balancer itself sits on multiple regions, but they are all clustered together. So to our cloud, it appears as one big entity which can scale across the cloud. What it does is we have like load balancers created in each region for a service. Let's say we have a service called ebay.com. ebay.com service has load balancer webs in each region. And then those webs will get provisioned on the global load balancer. So when client requests that I want to go to ebay.com, global load balancer will get a query because it's an authoritative DNS resolver for that address. It will respond back with an address, and that address will be one of the web IP on any of this region. Now, global load balancer itself is doing a health check on all the webs in all the regions. So if any region goes down, global load balancer will not respond with the web IP of that region. So once the global load balancer respond with IP, client will make subsequent call to one of those IP written by global load balancer and hence serve the request. So how we integrated this with C3, with our cloud is, so tenant, because the cloud, when user goes, our tenant goes in cloud UI, they can only see and everything which is in that region. They cannot see anything which are outside that region. So tenant goes to C3 to our cloud UI, and they click on a GLB bar, which is implemented by us. They go ahead and add a member, which is a load balancer they created in that region, to a GLB global load balancer in region 1. After that, tenant logs in to region 2's UI, and since they are using the same identity, since the keystone is global, they will see the same tenant has a GLB instance created from another region. So that's how we are scaling across the regions. Once they see the entry, a tenant can go ahead and add a member from region 2 to the same GLB instance. And they will achieve this kind of setup where LBs from multiple regions are added to the same GLB instance, and then you achieve the global load balancing this way. Okay. Now, next topic is advanced scheduler. So we figured very soon that to have multi-vendor, multi-VPC solution, we needed advanced scheduling, which does not come by default with OpenStack LBaaS. So we had to implement a two-stage scheduling algorithm, which makes LB selection based on multiple factors like VPC, virtual private cloud, where the tenants are coming from, what is the tenant SLA, how fast they want the service, what is their bandwidth requirement, what vendor they need, what fault domain they are looking. Like if it is production, we want it to be DR capable, so 3 fault domains for that. How loaded the LB is, whether tenant needs dedicated load balancer or shared load balancer. So based on all these factors, our logic determines which LB to pick for provisioning the web. So we have, again, going back to AZ level view, we have a Neutron. So when a client sends a request for LB provisioning through CLI or through UI or via API, the request goes to Neutron. Neutron gets the request. It does the first level scheduling to identify the vendor. Vendor selection is done based on SLA and the class of service. So once the vendor is selected, button is passed to LBaaS driver. Now each LBaaS driver here represents a vendor. So once LBaaS driver gets the request, then it has its own vendor-specific scheduler where it selects, it gets various metrics from LB, and it knows like I have 10 LBs and 5 are overloaded, so it will provision next 5 other 5 LBs with the new request. So now LBaaS driver can directly be talking to LB depending on what driver we are using, or it can talk to LBaaS agents, which in turn talk to the load balancers. So this is how our advanced scheduling logic looks like. And the last, which is, this is another addition outside default OpenStack LBaaS. We integrated our LBaaS with Designate. So Designate is DNS as a service. So LBaaS emits notification on LB creation and deletion. So we added that notification emission code, and that notification are targeted for designate consumption. So designate consumes those notification and creates or remove FQDN. Yeah, so that concludes my presentation. Do we have any questions?